Good morning, students. Now we will take HS second year mathematics class. Now, chapter 5, that is continuity and differentiability, we are doing, and exercise 5.1 we have finished up to question number 14. So now we are going to do question number 15. 15, here it is given that fx equal to twice x if x less than 0, 0 if x greater than 0, less than 1, 4x if x greater than 1. Of course, we have to find what? That point of discontinuity. Question number 15. Fx has three values. One value is twice x when x is less than 0, 0 if x is greater than equal to 0 and less than equal to 1, and another is 4x. So this is the question of question number 15. We have to find point of discontinuity. Students, you see that if x greater than 0, then only one value it is, that is twice x. So of course, for greater than 0, that is greater than 0 means what? Sorry, x less than 0, it is only one value. So less than 0 means minus 1, minus 2, minus 0.5. These all the values we are getting what? A fixed polynomial. So of course it is what? Continuous. So less than 0 we are getting a continuous. In between 0 and 1 we are getting a constant function 0. So they are also continuous. Greater than 1 value is 4x, so it is also continuous. So we are getting for less than 0, it is continuous. Greater than 0, less than 1, it is also continuous. Greater than 1, it is also continuous. Then what is our disturbing point? Disturbing point is at 0, because less than 0 gives one value, x less than 0 is twice x, whereas greater than 0 gives what? 0. This point, at that point we will check, and again for less than 1 and greater than 1 different value is there, so at that point also we will check. So for x equal to 0, our left hand limit, that is limit fx, x tends to 0 minus. 0 minus, of course we know it is what? Little less than 0. So limit x tends to 0, fx is what? Twice x when it is less than 0. If we would draw the limit, 2 into 0 gives 0. Now right hand limit fx, x tends to 0 plus. 0 plus means greater than 0. So x greater than 0, then fx is what? 0. So if you draw the limit, it gives the value 0. Now f0 is what? X equal to 0, then fx is 0. So that is 0. So what we are getting, therefore LHL is equal to RHL is equal to f0. Therefore fx is continuous at x equal to 0. So we are getting this one, that at this 0, where we may assume that this is what disturbing point, that gives what? A continuous values. Now we will get what? For x equal to 1. Simply we will change these things. This is 1. So here, if we take x equal to 1, then left hand limit x tends to 1 minus, this is less than 1, this gives what? A value 0. So then its value becomes 0. If we take right hand limit, then 1 plus little greater than 1, this is what? 4x. So we will write 4x. If we put 1 here, then it becomes 4. Whereas f1 it gives the value 0. So what we get? LHL, RHL, F1 all are not equal. So Fx is what? Discontinuous at x equal to 1. So it is the point of discontinuity in question number 15. Now similar way we will do the question number 16. But I found 16 is also similar. So similar sum we have to skip, and that will remain as homework for you. It is the 2-3 sum of same kind it is given as homework. But I am giving extra homework also, which is not inside the book, because these things though I will give the note. So question number 16 we can skip as it is similar like that of question number 15. We will now proceed to question number 17, which is little bit different from what sum we have done. From that sum, it is little bit different. So we will go for question number 17. 17 they said, find the values of a and b so that the function defined by fx equal to ax plus 1 if x less than equal to 3, bx plus 3 if x greater than 3 is continuous at x equal to 3. Here you see that in this question they have given that fx is continuous at x equal to 3. What we are proving in other sum, অন্য অঙ্কেতে আমরা প্রুভ করতে হয়েছে যে এটা কন্টিনিউয়াস কিনা এই পয়েন্টে, কিন্তু এটা এবার দেওয়া বলে দিয়েছে it is they have already supplied yes fx is continuous at x equal to 3, and in the values of x two unknown terms given, one is a another is b. We have to find the values of these unknown terms a and b. দুইটা unknown term দেওয়া সেটা ভ্যালু বের করতে হবে. So this is our question number 17. There fx say ax plus 1 when x less than equal to 3, bx plus 3 as x greater than 3. So given what? This is continuous at x equal to 3. Given fx, this is continuous at x equal to 3. It is given. They have supplied. Here no need to prove that it is continuous. It is continuous. They have already given. Now what we have to prove here? We have to find. We have nothing to prove. We have to find something. What? The values of a and b. As it is given, this is continuous at x equal to 3. Of course, LHL. Therefore, limit fx x tends to 3 minus this, which is our LHL, should be equal to x tends to 3 plus RHL is equal to f3. So this is actually they have given, they are all equal because it is continuous. When x is little less than 3, this fx will be ax plus 1. Now 3 plus means little bigger than 3, x is greater than 3, then it is bx plus 3. Now f3 means x equal to 3. When x equal to 3, it will be what? Ax plus 1 is the value of fx, so f3 will be a into 3 plus 1. So these things we have written as we know. LHL is what, RHL is what, and f3 is what. Now if we would draw the limit, it will be a into 3 plus 1, b into 3 plus 3, and thrice a plus 1. This we will not continue because it is 2 times a written. Now if we consider only these two, it will be what? Thrice A minus thrice B. I have taken thrice B this side. 1 if we take in this side, it is 3 minus 1, 2. So what we get? They have said find the values, that is what is the relation in A and B. So A is what? A and B has this relation, means all the values of A and B which satisfies this condition are the values of A and B. Suppose if we put A as 0, then for that we can get a values of B is this one. So B will be what? If we put A is 0, then it is B is minus 2 by 3. If we put A is 1, then it will be what? B is I think 1 by 3. So here all the values of A and B which satisfies this condition is the required values. So you have to write values of A and B satisfy thrice A minus thrice B is equal to 3. In question, they may ask find the relation between A and B, or they may ask find the values of A and B. If they ask find the values of A and B, you have to say that it is the values of A and B for which this condition satisfies. Or if they ask find the relation, then you stop it here. So this is our question number 17. Now similarly we do the question number 18. 18 is also similar type. For what value of lambda is the function fx equal to lambda x square minus twice x if x less than equal to 0, and another value is fx is equal to 4x plus 1 if x greater than 0 is continuous at x equal to 0. Continuous is given at x equal to 0. You have to find the value of unknown term lambda. What about the continuity of x equal to 0? Okay, so let's start this question. Question number 2. Fx is given as lambda x square minus twice x when x less than equal to 0, and another value is 4x plus 1 when x greater than 0, given fx this is continuous at x equal to 0. So now we have to find the value of lambda. So here to find the values of lambda, remember so many methods are there. I will show one technique. If you comfortable with this one, you can copy, you can practice, you can write this one. If you don't find it is comfortable, you can choose other also. One sum has so many formulae, so many procedure. You just follow that which is your right one. Now here LHM, that is limit fx x tends to 0 minus. This is our LHM. If it is little less than 0, this one, then value is what? Here we will write at a time, as it is continuous, so we will write all the things together. We can write these things are equal, these three things are equal. Why? As it is continuous at x equal to 0. So we are now writing limit fx x tends to 0. 0 plus means little greater than 0, for that 4x plus 1. And f0 means what? If we put it 0 here, then lambda into 0 minus 0, that is 0 is 0. Now, if we withdraw this limit, what will be the value? 0. If we withdraw this one, this is what? 1 and is equal to 0. So what we can say? This is what? Impossible thing, because 0, 1, 0. So lambda should be a such type of value for which we can get these things. But as it is, we are finding that this is what? Quite impossible one. So that's one we will read. So we will tell that their fx is not continuous, which is impossible, not possible. Therefore, lambda has no value. No value means what? No real value for which fx is continuous at x equal to 0. Why we have written such type of declaration? Because this, you see, this is quite impossible one. That is, if we take this is continuous, then lambda will give such a peculiar thing that it will create this type of thing. So it is not possible. So that's why we will say that there does not exist any lambda, any real values of lambda for which x equal to 0. This question has another part. It is what? What about the continuity at x equal to 1? X equal to 1. If we consider x equal to 1, now we are proceeding to our next part of this question number 18. X equal to 1 is what? At it is what? Less than 0. This is what? Greater than 0. Our x is equal to 1 will always gives this one. So for x is equal to 1, you have to given it is continuous at x equal to 0. X equal to 1, they are silent. Now we have to check whether fx is continuous at x equal to 1 or not. Then, if we take limit fx, x tends to 1, then for that, x tends to 1 means what? These things we will consider. This is the for less than 0. So for that we will write it is 4x plus 1. What is the value of fx? Fx is 4x plus 1. Now, if we draw this limit, it is 4 into 1 plus 1, that is 5. Now, if we consider f1, then also as x greater than 0, so of course this we will consider for f1 also, so it is 5 again. So what we get? Therefore, limit fx x tends to 1 is equal to f1. Therefore, fx is continuous at x equal to 1. So with that, we conclude our question number 18. Now we will consider that question number 19. 19 we will do. Show that the function defined by gx equal to x minus greatest integral function x is discontinuous at all integral points. So now question number 19 we are going to do. Their question is given. It is there gx equal to x minus this one. Gx function value is what? X minus this third bracket is greatest integral function. Greatest integral function in class 11 we have done. This is in third bracket type thing, this one. If we put any integer here, then its value will remain same. That is the definition of this one. But if we put suppose 1.1, then it is 1, 1.7, 2.1, 2. That is, if we get this type of thing, suppose if we get minus 1.5, then it is minus 2. Here, you will find it is, if it is integer, if we put this place, then its value will remain same. But if we put any fraction type like that, any decimal type is not integer, then it is what? 1.1. So before getting 1.1, which integer is there? 1. We will write here 1. 1.7, getting 1.7, before getting 1.7 we are getting 1. So this is, so preceding one we are taking, যা আগেরটা নিতে হবে 2.1 এর ঠিক আগে কোন ইন্টিজার আছে 2 লিখে দিলাম। 3.7 আমি যদি লিখি তাহলে 3 লিখতে হবে। -1.5 এর আগের নাম্বারটা হচ্ছে -2, so this is we have written. Now we have to check that whether this function is not continuous at integral values. Let a be any integer. What we have taken, any arbitrary term a which is integer. Now if I consider limit gx x tends to a minus, that is little less than a, x tends to a minus, this is we will write. Now here if we draw the limit, we will put it here a, but if we put it here little less than a, suppose it is less than 2, then value is 1, less than 2 value is 1, less than 3 value is 2. So if I take x and it is what, little less than s, then its value will be a minus 1. Student, you concentrate on this one. Why this value is a? Because if you draw the limit, this will remain same, but it will create problem. This create problem how? That x is what? Little less than a, little, very small. When it is very little small, if it is integer, then though it is remain same, but it is not integer, it is little less than that integer. So of course before that integer we will consider. Now if you draw this bracket, a minus a is 0, minus a on this comes plus 1. So this is our left hand limit. So that part is very what you minutely watch this one, why a minus 1, but this is a. This is because if you draw the limit, value remains same, but this gives what? As a minus, it gives little 1 less than a. Now if we consider right hand limit gx, that is x minus this one, 1 plus, this is our right hand limit. If we put it 1, 1, but if we put little bit 1 there, so it is a, it little bit bigger than a, no problem, greater than 1, it is 1.1, gives 1, so this will remain a. So this is 0. So here you see that this value will remain same, because 1, it is, if it is little greater than 1, then value remains 1, little greater than 1, 1, little greater than 2, 2, little greater than a, this will give same value a. So left hand limit is 1, right hand limit is 0 part. If we consider g0, here it is 0, 0 minus 0 is 0. Therefore LHL not equal to RHL, though it is what? So they are not equal, because LHL RHL not equal. Therefore GX is not continuous at x equal to a. A is what? Any integer, not continuous at any integral value. So this way we will prove by taking an arbitrary one. We can prove this one. This is the one way of proving this one. You can take the solve the answer in another way also. So now it is question number 19 finished. I think, is there any parties? No. Now we will continue question number 20. Question number 20 is like that. Is the function x square minus sin x plus 5 is continuous at x equal to pi? So question number 20 we are going to write. Here fx is given as x square minus sin x plus 5. And we have to prove at x equal to pi whether fx is continuous or not. So how to do this type of sum? When we get this type of sum, then we will do what LHL, that is limit fx x tends to pi. I have written this one. Limit x tends to pi, x square minus sin x plus 5. If we draw the limit, it is pi square sin pi plus 5. Sin pi is sin 180 is 0. So if we put 0, it is pi square minus pi square plus 5. Similarly, f pi, if we write pi square minus sin pi, so it is again pi square plus 5. So what we get, limit fx x tends to pi is f pi. Therefore, fx is continuous at x equal to pi. So this is our answer. Simple one. This way we have solved the other sum also like that. So here we can directly use this one. Now before going to do question number 21, we will do little extra things for this. In question, exam question, they may ask find the continuity of sine function. That is, this is extra one question. Here fx is suppose sin x. How to show that this function fx is equal to sin x is continuous function? How to show? Here limit fx x tends to a I have taken. A is of course arbitrary point. For that we have to consider x is equal to a plus h. What we have to put? X is equal to a plus h. X tends to a means what? X is approaches towards a. When if we put x equal to here, h definitely tends to 0. h যদি 0 কাছে না যায় তাহলে x এর কাছে আসতে পারবে না. So now we are writing x replacing by what? A plus h. And here h tends to 0. This point you have to note that the technique of solving, technique of proving that whether trigonometrical function fx equal to sin x is continuous function or not, this is the technique. It is not as usual we are doing in other cases. Here we are putting a new things, that is x equal to a plus h. X tends to a, so x if approaches towards a is definitely it is tends to 0. These things you have to remember. Now limit h tends to 0. Sin a plus h means what? Sin a cos h, cos a sin h. Sin a plus b formula. Sin a plus b what? Sin a cos b plus cos a sin b. Now this is if we draw the limit, h we have to put 0. Cos 0 is what? 1. This is the constant, so sin a only. And here if you put h equal to 0 here, sin 0 is 0, this terms becomes 0. So what we get? Limit of x tends to a is sin a. Sin a means fa, because fx is sin x. Therefore fx is continuous function. Why continuous? Because fx is continuous at x equal to a and b. So this way we can solve that fx is continuous function. Now if we put here cos x, tan x, other thing also, then similar way we can prove that it is what, continuous or not. This is required for solving our question number 21, because there we will use the trigonometric ratios, that is sin theta, cos theta, tan theta, sec theta, or other, that is sin x plus cos x, tan x plus sec x. If this type of things is there, how we can solve, how we can say that this is continuous function. So I think we can do, if you put fx equal to cos x, similar way we can do. Then after next class, this class we will do that much only. Next class we will do question number, that is 21, next one. So with that we end our today's class.